Hello. Today I will explain how to use Software Factory to manage virtual OSP deployment and update. The first part will be about the advantage to use Software Factory to manage an OSP deployment. The second part will be about the tool we use. The third part will be about the workflow and architecture, following by a demo. During this demo, the first step will be to deploy the OpenStack. The second step will be to update the OpenStack. The next part will be about limitation. As we do the deployment within an OpenStack tenant, we have some network limitation. And the last part will be about the improvement. There is a lot of advantage to use Software Factory to do the deployment. We have a cross-project gating system, there is a code review system to ensure pair validation, and it's a reproducible test environment. On the Software Factory side, we use 3 services. I will use Git as a version control system to manage the template and deployment script. On the Software Factory side, we use Gerrit for the code review, Zool as a gating tool to merge change only when tests succeed, and Jenkins to run the user-defined test script. We also use Python OOO helper. So it's a library who provide a complete Python API to drive an OpenStack deployment with OOO. It allows us to deploy OSP with OOO within an OpenStack tenant. We can also deploy a virtual OSPD using the bare metal workflow with IPMI command. It's similar to OVB, but with OVB, at least with OSP 7.2, we need to disable some security rule in Neutron. Python OOO helper is the solution for us. In this demo, we will deploy 4 nodes. 1 controller and 1 compute has the overcload node, 1 undercload node, and 1 BMC to simulate the IPMI. Here's the workflow with Software Factory. First, we have to submit a review with the template, the test script, and the deployment command. After that, when the review is approved, the get jobs are executed. If the tenant is empty, the deployment will start. Basically, it's create 4 instances, prepare the undercload, and do the deployment and deploy the overcload. At the end of this process, the reviews is merged. Now, I will do a demo. I will start by doing a presentation about the Git repository. The next step will be to do a deployment, and the last step will be to do an update. In the Git repository, we have the pipeline script for Software Factory. It's the 2 scripts OVB deploy and run test. We have 1 script to manage the OSP deployment, contains the deployment command and the template directory. And we have 1 configuration file for Python OOO helper. And we have 1 patches, also for Python OOO helper. As Python OOO helper doesn't have an update command, I have to patch it. So we will start by the deployment command. And also we have a simple template. So for this deployment, we will change only default parameter, the DNS server, and the deployment command. It's a standard command used to deploy OSP. The script run test.sh, it's used by the check pipeline. It's a pipeline used when you submit a review. The second one, OVB deploy. This one is used to set up the slave. So basically, in the first step, we will install Python OOO helper. In the second function, we just create the full OOO helper YAML file with my credential to register to Red Hat repository. And after that, we have 2 functions. The first one is install OSP, where we call OVB to do the provisioning step basically it only creates the instances and the network. The undercloud step where we will configure the undercloud, and the next step, the overcload step, will be to deploy the OpenStack. And the other command, update OSP, is just to do the update if there is already an OpenStack installed. Here we have the Python O helper configuration file with the data for the provisioner, for example, the different flavor to use, one flavor for the overcloud and one flavor for the undercloud. We have the directory for the template and the deployment command. And we have also the repository information to install the undercloud, and also one floating IP to be able to join the undercloud after the installation. So I have prepared the template file. Now we will submit a review. If we have a look at the tool status page, we normally going to see the demo triple helper check pipeline script. So it's finished. It's really quick. Now we can validate the review. And the get job will start in a few seconds. And now we can go on the job itself to see what's going on. So we are in the first step on the VB install script. So basically it's only install Python triple helper. And when it will be finished, the installation, the provisioning part for the Python triple helper will start. And I will stop the recording as we need 1 hour and a half to do the full deployment. I will come back later. So the provisioning step is starting. The installation is finished. We can now get the merged review. And we can connect to the undercloud with the public IP to check if everything is okay. We can connect to one controller, for example, to check the DNS value. So it's okay. Now we will do an update. For that, we have to submit a new review. We can check the check pipeline script. So everything is okay, it's a success. We can now validate the review. Now, like before, we have to wait for the get job, and it will be the same process. Spawn a slave, install Python triple helper on the slave, and start the update command. So it's the same process on the installation one. Basically, the first step is to configure the slave. And the next step will be to launch the update command. It's shorter than the installation, only 20 minutes. So I will cut the recording and come back in a few minutes. The update is a success. We can now merge the last review. I will now describe the limitation. As we do the deployment on an OpenStack tenant, we have some limitation, especially about networking and storage. On our setup, it's not possible to test network isolation with VLAN easily, because we need to modify the MTU for the whole platform to be able to do that. It's also not possible to have two interfaces on the same network for an instance, so we can't test bonding. It could be difficult to test external storage, SAN or external Ceph. And also, with Python triple helper, at this time, it's not possible to have more than one OSD per Ceph node. The last thing we need is a huge tenant to be able to test a big deployment with 3 controllers, 2 compute, and 3 Ceph nodes. As demonstrated, it's very easy to manage OSPD lifecycle with Software Factory. In the future, we can imagine to use differently the Zoom pipeline. For example, use the check job to do the update on pre-production and use the get one to do the same thing on production. Another interesting test could be to do an upgrade from OSP to the next OSP version. Also, manage a bare metal deployment could be really interesting. On Python triple helper side, we have to improve Python triple helper to have a different flavor for each role to help us to reduce the size of the tenant. And also have the ability to create more than one OSD per safe flavor. So the demo is now finished. Thank you for watching.